Okay guys, so hello and welcome to my talk. Today we're going to speak about a lot of things that we're going to try to do better. Whether it's going to be 33 things precisely, I'm not so sure. You have to come up with a nice title if you want to be accepted at such a nice conference, and especially if it's like, 33rd degree, you have to have 33 in your name, in the name of the session. And it's also like 33 degrees outside, so everything matches perfectly. So before we begin, let's have the boring part done. Let me introduce myself to you. My name is Tom, or Tomek. I work for SBB in Bern in Switzerland, which is a national rail provider. You can find me on Twitter at @Bujok, or you can also visit my blog, refistio.org. And I'm also like a co-founder of the IT recruitment startup called No Fluff Jobs. So if you're pissed off by the fluff in the IT recruitment, visit the website in 1 or 2 weeks. Okay, let us begin. So let us imagine that we want to order a wardrobe, like a wooden handmade wardrobe. And we go to a carpenter and we say, listen, Mr. Carpenter, I want to order a wardrobe. But it doesn't really matter if it, stands straight. It may be like the Leaning Tower of Pisa, so that I'm gonna, push it into the corner so that it doesn't collapse. And when it comes to the wood that you are supposed to use, it doesn't really matter. Just take any bits and pieces. And it also doesn't matter what kind of varnish or what kind of paint you put on it. Just give me the raw thing. And when it comes to the doors, it also doesn't really matter. You can fit one door or you can fit the pair of doors, but they do not really have to look alike. Just give me the thing that you produce from any kind of materials that you have in your workshop. So what do you think the guy would think of us? And it's a rhetorical question. If we just showed up and placed such an order. If he was a serious craftsman, he would probably think, oh yeah, that these guys are crazy, or they want to produce like a piece of junk, or we are not simply kidding, or we are joking. And the second rhetorical question that I want to ask is, what would we think of the guy if we showed up and placed such an order? Would we think that the guy is a serious craftsman, or maybe we would think that he simply accepts this order because he's also crazy, or he doesn't have enough commissions, so he simply wants to do anything and he would accept such an order? So having that carpenter example in mind, let us challenge the following statement, which is the code that we produce is bad. And don't be offended by the statement if you are, like a geeky coder and your code is always picture perfect and well crafted and well tested. When I say the code that we produce is bad, I don't mean it's always bad. I mean this code is bad sometimes, frequently, often, or actually most of the time. So if you've worked for a big financial institution like a bank or like a serious insurance company, you could probably testify together with me that the code is like a big ball of mud. It's a spaghetti code jungle. And you simply, when you look at it, you simply do not recognize anything, because these are like simply bits and pieces that are joined together. So whenever John, like an average IT developer working for this average IT bank department, when he has to introduce a new feature because the manager comes into his room and says, listen, John, we are expecting an increased traffic in business transactions over the weekend. And of course, it's Thursday, and we have to increase the capacity of our system, let's say by 40%. John, without any problems, without blinking his eye, he can take a very nice piece of engineering of the system that he has already created that you can see in this picture, and by injecting a caching bean on the top, he can solve it like this in 10 minutes. And what is the reason why we IT guys produce such crap? What is the reason? We'll try to have a look at this situation and we'll try to recognize some of the reasons. And the first one is that we do not have well-defined standards. We still do not have them. And if I told you, for example, that we want to produce a vehicle, and I told you it is supposed to have an engine, and it is supposed to have 2 wheels, you would say, yeah, it's probably like a motorbike. And if I told you it is supposed to have like 4 wheels, then you would say, oh, it's a car. And we have like many kinds of cars, many types of cars. We have like an SUV or a sports car, luxury car, or a convertible, or or a truck, lorry, and all kinds of cars, like multiple cars. And if you see a car in the street, you look at it, and in 90% of the cases, you recognize what kind of car it is. Whereas when we begin our new assignment, let's say a new project, and we sit in front of a computer, we work for this big, serious financial institution, and if after 8 hours, if we make our project compile in our IDE, and if we browse the code and look at the classes, I would say in 80% of the cases, we have no idea what the system is doing. And I can give you another example, also car related. I can bet with you that, let's say, in 90% of the cars, if I'm supposed to find a battery of this car, I can find it within 1 minute. Because I'm going to open the hood, I'm going to look to the left, oh, the battery is not there. So I'm going to look into the right, oh, the battery is there. Because there is a standard. You probably do not fit the battery under the body of the car because it doesn't make much sense. And whereas in our industry, on the other hand, when we have to adjust the, let's say, the settings of the transaction manager in our application, we can look in different locations. Let's say we can look into a custom property file, we can look into a custom XML file located somewhere in the project, we can look into the Spring configuration if we use Spring, we can look into the configuration of the deployment descriptor, or we can look into the settings of the application server. So it can take ages until the moment when we find it. So this is basically the first example. I'm going to go deeper into details here. And the second example is that we simply sometimes cannot say no. We cannot say no, and this is our problem, because we are geeky guys, and when we have an assignment, when we have a problem, when we have a challenge, and when we want to do something, it doesn't really matter that we cannot do it properly within a specific time range. And I can give you another example. Let's say that we have a valley, very beautiful valley with a river down there, and a guy comes, and we are a construction engineer, and the guy comes and says, listen, we have to build a bridge over the valley. But it doesn't really matter that, every second or every third car falls into the river, because it simply has to work somehow. Doesn't really matter. Do you recognize this pattern? There's been thousands of systems that's been implemented like this, and then you deploy it, and then you start the production version, and then you debug the log files until the end of your days, because you have no idea what has happened there. So we have looked at two reasons, but let us look at the third thing, which is our skills. How is it with our skills, our really low-level skills, our tiny skills that we use every day in our daily jobs? Is our conscience clear? Are they so perfect that we do not have to improve, that we simply use all the skills we've got and they are so perfect that, no problem at all? And in order to analyze this problem, let us look at the example of the football players. And the question that I have to you is, would they be that good? Like, for example, as Cristiano Ronaldo, if they didn't train at all? If they simply played a game every weekend or twice a week, they would simply gather, go to the coach, they would just drive to a game, they played, and that's it. Would they be that good? So in my opinion, and as I'm really into football, I read a lot of interviews, and what Cristiano Ronaldo says, he says that, when he learns a new trick, he trains and fails, and trains and fails, and he tries it in training, and he very rarely uses a new trick or tries a new trick in a game if he hasn't trained it during a training session, because it's very difficult. So they have skills that they gain in training, and of course they have skills that they gain during the game, but they cannot learn properly certain things if they do not train. An example that is related to us is, can we learn how to play football as a professional player if we simply play with guys in our neighborhood? Probably it's impossible, because there are certain techniques and things that you have to do and repeat in order to become a good football player. And you may ask a question now, okay, but how does it really relate to our IT industry that we all work in? And I can give you an IT-related example right away. So let us imagine that you have a situation that the manager comes and says, listen, John, we have to quickly execute the release of our project, and we have a Maven project. We use Maven, and we have like 30 sub-modules. And the problem of Maven in this situation is that, if you have a parent module, you have to hard code the version of the parent module in the children modules. So it's simply there referenced as a string. You cannot reference it using a property. It's simply hard-coded in the children pumps. So if you don't know, let's say, Maven release plugin, or if you don't know like a find, grep, and set combination, what you would think if you had 10 minutes? You'd probably think, yeah, I have 10 minutes, I have 30 files, I'm gonna open them in an editor, I'm gonna, edit the version, I'm gonna save it, commit it, and I'm done. Under this time pressure that you are experiencing in this particular situation, there's no chance you're gonna try, Googling how do I release with Maven release plugin, because the chance that you will not get it in this 10 minutes, it's really high. So we are trying to prove now that deploying our skills is almost mutually exclusive from mastering them. What I'm trying to say is that we have to master our skills, and then we have to deploy our skills. And deploying our skills is exclusive from mastering them. As the football players, of course, we can gain experience while we deploy our skills, but it's more on the top of the basic skills that we have already acquired beforehand. And we can also go one step further, and we can quote Aristotle, and we can say that in order to be excellent, we have to be excellent every day. We are what we repeatedly do. Excellent then is not an act, but a habit. So in order to be excellent, we have to be excellent every day, which means that we have to have excellent habits. And what is a habit? Habit is something that happens subconsciously. It's something that happens automatically. So for example, if I'm driving a car and I'm turning left, I'm turning on the left indicator, and if I'm turning right, I'm turning on the right indicator, and I'm not really thinking about it. It just happens subconsciously. Or if I'm driving and the car in front of me brakes, I'm not thinking, oh whoa, the gap is closing, so let me Google how do I brake. I'm simply implementing, deploying the skill that I have already acquired. And when we speak about habits, we have to say there are good habits and there are bad habits. And what we're going to concentrate on right now are the bad habits and how to eliminate them. Exactly. So bad habits by Catherine Murdoch, who wrote the book, The Psychology of a Habit, we have to recognize them and eliminate them as soon as possible. Because the older we get, the less flexible we get, and the more difficult it is to eliminate bad habits. So, the older we get, the less flexible we get, and the more frequent we repeat the bad habits, so the more difficult it gets to eliminate them. And the other problem is that if we have a bad habit, let's say we code up a builder pattern in the wrong way, simply in the wrong way, and we did it, let's say, 100 times, it's really difficult to implement it in a proper way for the 101st time, because we have already repeated it so many times that it simply gets difficult. So how can we actually eliminate the bad habits? And this is what we're going to try to do during the session when we move to the technical part in 1 minute. We'll try to eliminate the bad habits that we have already acquired. And how can we do it? We cannot simply say, okay, I coded up the builder pattern in the wrong way for 100 times, and I want to do it in a proper way for the 101st time. It's impossible. First, we have to learn how to do it in the proper way. And what Dr. Michael Russell says is that we cannot erase a habit. We have to learn a new thing. We have to somehow inject it into our habit loop, and then we can override the bad habit. So in our case, we have to train. We have to see how to implement the builder pattern in a proper way, and then we have to inject it into our habit loop. So when it gets into our habit loop, then it's certain that will overwrite it, and then the bad habit is eliminated. Okay, so that's a short recap of the theory part, and we're going to move to the technical part now. And what we're going to do in the technical part, we're going to simply have a look at some examples of code. We're going to look at bad habits and good habits, and we'll try to improve our skills. So in the part that is just finishing, we said that the code that we produce is bad most of the times. And we named a couple of reasons, but we basically concentrated on our skills. And what we said, that we have to train our skills, we have to train every day or frequently in order to get excellent, because in order to get excellent, we have to have excellent habits. We have also said that we have bad habits, meaning that we have some techniques that are shoddy, that we repeat, but they're not really proper. And we'll try to eliminate them today by overriding the bad habits with the good ones. So we're going to have a look at some techniques and technologies and frameworks right now, and we're going to try to, identify the bad habit, and we're going to have a look at the code samples. And I'm not going to show the bad habits. I'm just going to, briefly mention them. But as I reckon you're all geeky software developers since you attend this conference, so you can easily, imagine how the bad habit would look like. So the first framework that we're going to look at is called Lombok. It basically, its implementation is a total hack because it's not using public API, but it's stable. It works with Hibernate. It works with in production without any problems. So let us have a look at this domain class or a data object or value object called person. This one will not compile because it doesn't have a public constructor, but it doesn't matter in this case. So what do we have to do in order to make this class usable? Probably we need a constructor, probably we need some getters, probably if we want to store it in a map, we have to use some equals or hash code to make sure that the business value is equal the thing we are getting, and so on and so forth. And probably we would need like a two-string implementation in order just to print in some of the information to the console. So with Lombok, you can simply annotate this class like in Groovy, and the code is transformed during the compilation process, and you get these methods that are mentioned in this annotations in this slide. And and you may think, okay, but how do I use, let's say, the control space in my IDE to see what kind of methods are there if I want to use them? So basically, there are plugins for Eclipse and IntelliJ, so there's no problem. You do not lose your, let's say, code completion. And it works really, really well. Of course, you may say, yeah, but how do I debug these methods? You cannot debug them, that's true. But I mean, why would you like to debug a getter on a setter? If it's doing some more stuff, then probably it's not a simple getter of a set or a setter. It's a method. It's a business method that's doing something more. So the problem really doesn't exist. And the last problem, or the last issue, or the first issue with Lombok is that you basically generate Java docs out from the source code. So if you generate Java docs, you will not get Java docs for getters and setters. But yeah, I mean, probably you do not need them. And you may say, okay, but this is really a lot of annotations. So all of the annotations that you've seen in the previous slide, you can replace with the data annotations. And this is like a fully featured data object that spares you 100 of lines in your code base. So this was one example by Lombok. The second example is, you know how much code it is to code up a builder pattern. You have to have this static inner class, you have to have a builder method, and then you have to have a method for every field with validation and stuff like this. So it's really for, let's say, 10 attributes, it's over 100 lines. So with Lombok, you simply annotate the class with add builder, and the builder is generated for you. And if you annotate the class with the validators as well, it will consider them. So the builder methods will basically reuse the validators. So you spare, let's say, another 100 lines out of the box just by annotating the class. And as you can see in this slide down there, there's an example how you use the builder. It's a builder as defined by Joshua Bloch in the effective Java. Okay, we have some more examples by Lombok. Easy peasy, like in Groovy, you simply annotate your class with log4j and you get the logger. Private static final logger, log equals log factory, get logger, and you specify the class. This is like a boilerplate code. You don't have to really, you do it in every class when you want to log, you simply annotate it. And you've got the logger out of the box. Okay, now a quick question. How many of you are still using Java 5? One person, wow. How many of you are still using Java 6? Okay, let's say 30%. So this is for you. In Java 7, you have try with resources block, try catch block. So basically like a block that you don't have to inject try catch, finally try catch to close the resources in your method. You do it in Java 7 or 8 out of the box. But if you're using Java 5 or Java 6, you can annotate the resources that implement closable with @cleanup annotation, and you avoid this boilerplate code, which is, yeah, try catch, finally try catch. Okay, this was Lombok, pretty quick, but basically pretty useful, works really well, and yeah, try it out and see if it works for you. The next example is Guava by Google. It's standard as well. I'm just going to show some non-standard examples maybe. The first thing is optional. So how many of you still return null or null in your methods if it's not returning a proper value? Raise your hand. Yeah. Wow. Everybody. So how many of you are using optional? Yeah. So the rest of you is sleeping because maybe 20% of people raise their hands. So with optional, what I love about optional is that if I see that a method returns optional, I have to, explicitly, I have to think, will there be a value or not? And if a method returns an object and somebody implemented this method in such a way that it returns null, I don't have to pay attention to it. I can just take the return value and do something with it. And boom, null pointer exception. Of course, you can annotate the method with a nullable annotation and some smart IDEs like IntelliJ. It will highlight this line and tell you, okay, it may generate a null pointer exception. But if you don't use nullable, you can use optional, which is really sweet. It's implemented. You don't have to do it by yourself. It's a really small class, but it's useful in many cases if your method is not supposed to return business value all of the time. Yep, some other examples like preconditions. It's a really cool validators. I'm not gonna concentrate on all of them, but I love the last one, which is checking if the value of an attribute is not null, and it returns this value as well. So as you can see, I can assign the validation statement to the current user local variable. I don't have to waste lines on checking if it's not null and then I'm assigning or not. I'm basically doing it in one line, which spurs a lot of code, boilerplate code as well. Okay, so for people who are still using Java 6 and 5, yeah, I didn't ask how many are using Java 4, but hopefully nobody. Yeah, so in Java 6, when you instantiate a map or simply a generic type, you have to repeat the generic declaration that you already see in the local variable in this example, which is kind of, it's annoying because, you can already figure it out from the declaration. So if you are using Java 7, you can omit them. But if you are using Java 6 or 5, you can use the maps new hash map method. It's a static method, and it's using, the type inference to check out what kind of map it is. It's like a generic trickery, but you don't have to repeat it, which is really cool. And yeah, and it's first simply coding of annoying declarations. Yep, the last thing of the basic examples is are the multimaps. Multimaps are simply situations where you have to store another collection in a map. So let's say if you map a string to a list of values, or a string to a set of values, and so on and so forth. You have an implementation from Google, and which is really sweet as well, because I guess everybody has once implemented a method that is checking if the second map is already in the first map, and if yes, you can insert the value, but if no, you have to instantiate it, you have to insert it into the first map, and then you can use it, which is a lot of boilerplate code. And with Guava collections, multi-maps, you just omit it, you just use it as it is, and it does all the trickery for you. And it will always return an empty collection if the value is not there, so you are null safe. Okay, LambdaJ, really cool thing, another framework. Yeah, just quickly, as we have people who cannot use. Oh, how many of you are using Java 8 already in production? Ah, yeah, exactly. One person? I want to work for a company. And okay, in development, wow, 2 additional people. Okay, so 3 people out of I don't know how many, but yeah, exactly. That's the problem. So they released it, but our operation managers are not really happy about it. We're still gonna wait maybe 1 or 2 years. And there's also no WebSphere, FEAR implementation using Java 8. So yeah, we are still stuck with Java 7. With LambdaJ, you can have some functional statements like filtering a collection using some proxies and stuff like this. But it is really cool if you have to filter a collection. You can use either a Guava predicates, or you can use LambdaJ for the filter statements, and there's kind of a couple of predicates that you can use inside. And yeah, it's pretty readable. You don't have to do for each loop with a list of results, and you don't have to insert them. It's boilerplate code, and we don't really want to code such crap, so we use stuff that's more readable, and we use stuff that's more useful. With LambdaJ, you can do it. Yeah, you can also have closures with LambdaJ. It's just like a brief example. There is this semicolon over there after the closure method invocation, which makes it a bit more ugly, as if it was like, yeah, it would be much more beautiful without this colon, but still there is a closure. It's using a lot of magic behind the scenes, but if you want to have a look at it, just yeah, as an example, what people did with Java 7, waiting for closures and being frustrated, you can have a look at this example at home as well. Some more basic stuff before we move to another area. What is the difference between these 2 highlighted lines? Who can tell me? Raise your hand. Yep, a person there in the middle. Exactly. The first example loses the stack trace. That's the correct answer. Yes, it will invoke the toString on the exception, and you will see a very beautiful message of the exception, but you will not see the stack trace. And you may think, yeah, it's really basic, but you see these systems in production, you know, logging such stuff every day, and you have absolutely no idea what happened. You just see the exception in the message, but you don't know what exactly happened. Log4j is not really safe in this situation. You have to watch out. You have to insert the message, and then you can pass the throwable to the log method in order to log the stack trace. With SLF4j, you don't have to do it because the first example will not compile. You always have to insert the message, and it will always log the stack trace. Yeah, SLF4j or Logback or other modern loggers can do it for you. And you can also see the parents in the message. You can parameterize your message without string format. That's kind of cumbersome. And here you don't have to, you know, it doesn't play any role what kind of type it is. You simply use the parents and enter the values, and it's gonna do the magic for you. And what is also cool about it, if you log a lot and you have different, you know, you use different levels like info, warning, and whatever, and you want to disable info, but you have a lot of info statements in your code, by using the parameterization, you avoid the evaluation of the string before the message is logged. Because what log4j would do if it wasn't parameterized and you used, let's say, string concatenation, it would concatenate the string, it would enter the log info message, and it would check if info enabled, then it will say no, and then but the message is already evaluated and built, which doesn't make sense. So with SLF4j, Logback, and other cool things, you can avoid it and have cleaner and shorter code. Okay, the last example is the bad defaults that we basically use and generate every day. yeah, basically that's the thing that Eclipse or IntelliJ will generate for you if you do add catch, try catch block and generate it. It will simply do the print stack trace, and you can see the systems in production as well pretty often. So I change it to something like this so that I'm sure that that my system is not working properly in case such an exceptional situation occurs. And yeah, I'm sure that it's going to be rethrown and somebody will notice it, because otherwise it's simply a log statement somewhere in the console and you don't really have to see it. And the last trick when it comes to try catching, how many of you have seen such statement in your code? Raise your hands. Yeah, exactly. It's about maybe 25 or 30%. So yeah, you have basically two solutions. I saw it somewhere, and I think it works like it works miracles. It's at like 100% success rate. I should sell it and patent it. Basically, one thing is you can argue with the guy and you can go and say, oh, it doesn't really work. You shouldn't do such things because you are not sure if it's not gonna happen or how sure you are and blah blah blah. And if the guy is a nerd and he doesn't want to listen to you, you simply you lost the discussion from at the very beginning. But what I do in such situations, I simply insert something like this, and I commit it, without discussing with these people. And and the usual time span of the discussion is like within 1 week. They always come. They always come and they want to discuss it with you, and yeah, and it never stays like this. So you can either try, discussing beforehand, but it's much more easy. It's easier to insert the statement, commit it, and then it's like a delayed trigger. But it has never stayed like this in my code base, at least. The last bad default is, does everything have to be public? Does it have to be public by default? When we generate a class in our IDE, it's always public by default, which is really annoying. If I see a need to make something public, I make it public and I do it. But if I don't see the need, why should it be public from the very beginning? It's annoying, and yeah, you can just change the default of your IDE to generate package protected or whatever you wish. But if you have to deliver some API that has to be backward compatible, everything that was public in the first version has to be public in the second version, otherwise you are not backward compatible. Okay, quickly, Effective Java Clean Code. I hope you have read these books. You look at them, read them. Every Java developer who wants to be a solid craftsman is supposed to read these books. So read these books. They're really cool. There's a lot of examples like this in these books. We go further. Remember, John developer. We don't want to produce code that John produces. So another example: John takes this system, and if he doesn't know the stuff that we were just discussing, and he has to increase the speed of this car, he does something like this. We don't want to do it, so we look at the technologies. Now we go into testing. Unitils, pretty awesome library. I haven't heard of it. I heard of it lately, and it's really cool. For example, if you want to read the content of a file in your test, you use the file content annotation. You don't have to play with some commons IO stuff. It's done for you out of the box. Temp file works miracles as well. You just annotate the file with the temp file annotation, and it works well. The only drawback of this library is that it has to extend the unitils JUnit4 class, which is like a parent class for all of the JUnitils convenience. But yeah, this project is pretty impressive, and I hope they will work on some runner, JUnit runner, so that you can avoid this stuff. It's not very sweet. But apart from that, all of the things that are there are really cool, and you just encourage you to have a look at this. Some other cool things are assert reflection equals. So if you don't have a equals and hashcode method implemented in your objects, but you want to compare the business value, the value of the fields, not compare the instances, then you can use the assert reflection equals. There's also some cool stuff if you want to compare lists. I know there's other convenience for it as well, but I guess everybody has once created a sorter in their test code in order to sort the list, in order to compare them with normal equals in JUnit. but with unitils you can avoid it. You can just specify the order. If you specify lenient order, then the order of the elements in the list will not really play any role. Okay, some more hardcore stuff by unitils. I guess everybody has once seen a singleton that is implemented, let's say, in a imperfect way, when there is a private static final field that creates an instance of the singleton. There's an instance field, and we use it. If you want to test it, and if you want to inject other value into, as the singleton reference, as the singleton instance, you are unable to do it, because it's going to be populated in the test. It's going to be assigned to this variable, and you're done. You cannot really change it. You can do this with bytecode manipulations, and you can also use the unitils, which will do it out of the box for you. You simply say inject into, and you have also inject into static, and you can say which attribute of which object, and it's going to be injected for you. So if you want to test something like this, you use these annotations, and you can inject your mock there, verifying that some particular operations have been executed on the singleton. Okay, unitils, pretty nice example of a library that makes your testing easier and shorter. Some other example is JUnit params. So how many of you have ever used the parameterized JUnit tests? Okay, let's say 35% again. Yeah, so do you like the collection of array of objects that you have to inject, that you have to populate in the method that returns the values to your test? I find it really annoying. It's really ugly code. So if you use JUnit and you cannot use any other library, you use JUnit params, and you can use the add parameters annotation, where you can inject some simple values to the test method. And if you have a more complex example and you need some kind of a provider or a method that delivers the values, you can use the really nice dollar notation that was introduced in this library, that's going to populate the arrays for you, but it looks much more cleaner. It's cleaner and shorter and much more readable than the really long code that you normally implement when you use JUnit. Okay, the next really cool convenience is called awaitility. We are still in the testing area. So how many of you have ever implemented a multi-threaded test, and you have a while true loop in order to wait for some events to finish, because you have to then do some kind of assertions? How many of you have once in their life did stuff like this? Yeah, exactly. There's only like, maybe 5 or 10%, so it means other people are ashamed to say, but probably normally it's kind of a higher percentage. Yep, with awaitility, you use really cool static methods to specify the wait condition. You say that you wait at most 10 seconds, or you wait until a method was called, and the result was free, or as in the second example, test with atomic number, you can simply say that you have an atomic integer and you wait until it's equal to 1. You don't have to implement custom stuff. You just use awaitility, and your test code that uses some threading stuff is then much cleaner and nicer. Okay, we are still in the testing area. There's a couple of more frameworks and technologies I want to show you. So the second to last test framework is called Byteman. So it is not, so the frameworks that I'm showing you, it's not like this that you are supposed to use them at the very beginning and all of them at once. You simply have to see what it does. You have to evaluate it by yourself. You have to play with it, and then when you see a case where you can use it, you are supposed to know that something like this exists. But all the hard work, of playing with it and learning it, you have to do by yourself at home or at work. And Byteman is one of these tools. I am not saying that you have to use it all the time, but sometimes there are these situations where you need to, when you're implementing some tests and there's a really complex case, and you cannot play with the input parameters in such a way that a certain part of code that's somewhere deeper in the hierarchy of the invocations, that you cannot simply reach it. So you cannot verify whether block A or block B has been invoked to see what the value at the end of the method invocation was. With Byteman, you can simply instrument the code using some bytecode manipulations using these annotations, as you can see, and what you can say is that the target method of an object, in this case, is an inner class called stock service of our test. It's a really short example. When the method getQuote is invoked, it will throw a new runtime exception. This is pretty cool and pretty neat in such situations. There's not much configuring that you have to do in your test configuration. You simply specify a Byteman plugin, Maven plugin, or a test runner, or stuff like this, and and it works out of the box. And in this case, the test, because I'm invoking the getQuote method, it will throw a new runtime exception. And as you can see, this exception is expected, so the test will be green. It will pass without any problems. So if you see such a need, if you have such situations, don't implement some bytecode manipulation code by yourself. It doesn't pay off. It's a lot of trickery. Try to use things that really does the hard work for you out of the box. And the last example, framework that I really love, is called Spock. Yes, you can say it's Groovy, but who cares? You know, Groovy is just a library or just a dependency that you can add to your build Gradle or POM XML file. And, you know, if you have some corporate policies that say that you cannot use Groovy or you are not allowed to use Groovy in production code, you can begin by, using it in tests. You just add one jar to the POM XML file. If you commit it at night, nobody will notice. And you can start implementing the tests in Groovy in Spock. It's really cool. You can test your Java code, so it's not a problem. And as I will show you, the tests are really sweet. You know, with JUnit, there's no convention. So I pretty often see tests that have 100 or 200 lines, and there's some preparation, invocation, there are some asserts in for loops. And if you look at the test, you have absolutely no idea what it's testing. And when it's working, then you are basically on the safe side. But when it starts failing, then you spend 20 minutes debugging this peep to see what it's really doing. And with Spock, you can use the inbuilt expect where or setup when then DSL, which makes your tests readable from the very beginning. And what is really cool here is if you have a convenience method, let's say like right now we are testing string utils is blank method, but as you can see, you have two columns with the input and the result, and it simply specifies test cases for your convenience method. So you don't have to have separate methods. You have one method, you insert all the values into two columns, and then it's being executed. And you can also see the unroll annotation at the very top of the method. It will basically unroll the test. So when you execute this test in your IDE, you will see it as a let's say 10 methods invocation, or in this case it's going to be 1, 2, 3, 4, 5. So it's going to be as if it were 5 cases. So it's not like this that you implement all the logic in one test. You are simply smart, you have one method, and it's like 5 JUnit tests. Yep, this is setup when then. Another example by Spock. Spock is really like a broad framework, but it's easy to learn, and I encourage you to really have a look at it because it's really usable. And in this example, you see that with then section, we use the Groovy mocks, and we just evaluate if the methods received on John and Jim have been invoked once on every object. So it's not Mockito when and stuff like this. Simply 1 multiplied by the method invocation, and and it's really readable and sweet. Okie dokie. We have a couple of more minutes. We're gonna jump into Groovy now. So we've covered Spock, which is the introduction into Groovy. As I said, Groovy is really cool, and I have an example. I think I've presented it before during some other talk, but just to show you what Groovy can do for you, I'm gonna show you some XML parsing. So we're gonna do really sophisticated XML parsing here. We'll take this XML, really complex and big, and we want to println the names of the banks. So what we are expecting on the output is Citibank and UBS. And we're gonna do it using the vanilla Java example from the Oracle website. So if you do XML parsing, Oracle, blah, 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 in Java, you're gonna see something like this. And I know there are some parsers and stuff like this, but I'm just a simple guy. I use vanilla Java. And look at the for loop. It's forget about it that you can use the for each loop. You just have to use the C++ style, and you get a node, and still you have to check node get node type equals node element. So I get a node, but I still check if it's a node, and stuff like this. In Groovy, you can parse it using basically one-liner. I split it into 2 lines because it couldn't fit the slide being readable, but in IDE it's one line, and you use the dot notation and you navigate in the XML hierarchy of your document. So I'm not saying use Groovy for everything, but come on guys, it's like 2014. There are simple tools, certain tools that you can use in your project, and you don't have to do everything with the hammer, which is Java 7 in our case. Okay, 4 minutes left. Grape, another really cool Groovy framework. If you want to code up Bash, let's say scripts, console scripts, normally you would do it in Bash or in Perl or in any other scripting language that it's available on Linux. But if you want to use Java, or in this case Groovy, which is basically like Java plus something, you can use Grape, and you implement logic of your script in Groovy, and you can also suck in all the dependencies that are required by your script. So in this case, it's a stupid example. We're going to use common slang. But if you have some logic from a jar that you want to invoke in a script, and you don't want to use Bash because it's more complex and you are familiar with Java, just use Groovy and Grape, and you can execute it as a normal Bash or shell script on Linux without any problems, or on Windows. So with Grape, you're going to use the dependencies like in Maven without any problems. Yeah, speaking about the Maven and Gradle, this is like a standard build example by Maven and Gradle. I use Maven and I use Gradle. I think both are cool. I could do everything I wanted in Maven without, maybe without any problems is too much, but yeah, it worked. Yeah, the poem maybe was a kind of a bit long and I couldn't understand it, but it worked. With Gradle, you can see this is a standard build example. It's kind of 3 times shorter or 2 something times shorter. Just play with it, just to know what is there, what you can use, because you can be stuck with Maven for another 20 years. And if you don't try out things that are there, you will not use them. Yep, the last section, we have a couple of more slides and 2 minutes to go. The first thing is Git. How many of you are using Git? Yep. Okay, it's a majority, maybe 60%. Yeah, with these 20 commands, so I address people who do not use Git now. With these 20 commands, you are pretty good with Git. It's not like this that it's a totally complex thing that you have to train for 3 months in order to use it. But you get a lot of convenience on the top that's really useful and helpful. So just learn these commands and try out Git. It's simply a new quality of source code repository. Another thing is like Bash and stuff like this. I know some people hate it. I know some people want to do everything in their IDEs, but there is this day, and it's normally Friday at 5, when there's a problem in a production server and you have the console only, and you simply have to check some value of some files, and you have to look for these files, and if you want to leave your job or your everyday job at 6 and have a nice weekend, you have to have some Swiss Army knife tools in your pocket to look for these files and to check some values. So I encourage you to train with Bash. There's a couple of commands that you have to know by heart so that you don't have to really Google this stuff, because it's sometimes complex, or sometimes it's really unintuitive for Java developers. So just learn them by heart. Just have a a toolbox of 10 commands that you basically grasp, and you leave your job at 6 and have a nice weekend in this case. Okay, the next example is Project Baboon, which is authored by me and released a couple of weeks ago. So how many of you are using Windows as a main operating system at your job? Okay, maybe 50-60%. Yep. So there's, as you know, there's Windows PowerShell. If you know it, then you are on a safe side. But if you don't know it, then you can use some Cygwin, or you can do everything in your IDE. But it's cumbersome, you have to install all the things manually, you have to configure them, and some things do not work on Cygwin out of the box. You waste time on configuring every tiny feature of your Cygwin installation. So with Baboon, it's basically a pre-configured Cygwin instance with a package manager like apt-get or yum, and you also get a lot of convenience like pre-configured Git, a lot of developer tools, and a silent command line installer where you install Baboon, just executing a bat script that doesn't need admin rights. It's pretty cool. Yeah, it got a lot of good reviews on GitHub. So yeah, if you are looking for a console, have a look at it. Yep, we are coming to an end. The last thing that I want to cover when it comes to technologies and frameworks is your IDE. I know that you can do everything with mouse and right click and stuff like this, but sometimes it's not really the perfect way, or it's the best possible way to work with your computer. You are smart enough to learn some new things like, let's say, keyboard shortcuts, and you are better off when you just grasp them. If you have to learn quickly for a call hierarchy or where this method is called, you can use the right click and context menu and navigate and click, or you can simply press a magic combination and you see the results immediately. So for example, in IntelliJ, there's a really cool plugin that when you execute some kind of a mouse click combination, it will show you the shortcut that does the thing. So you learn only the shortcuts that you like and that you use frequently. Okay, so this is the last topic, which is code review. It's kind of a soft topic, but I think it's also important. So how many of you are doing code reviews on a regular basis? Yep, that's cool. Also 50%. So I see a problem with code reviews. I mean, it's the best way to learn and the best way to check the quality of the code that's being checked in and stuff like this. But the problem is with us, and the problem is in our attitude. So if you talk to a guy and you say, hey, listen, you did it in a really nice way, but there's a better way to do it, so you can delete this method and you can just use one annotation and 100 lies are gone. And the guy says, yeah, but it works. Then the discussion is closed. And you can try, convincing the guy, but if his attitude is really closed and the discussion is, just cut at the very beginning, you cannot have the space for a proper nice discussion where both of you can learn. So what I really encourage people to do is to be totally open. If you are doing a code review, be positive, say positive words, say this is cool, but you can do it in a nicer way, and then it's gonna be even cooler. And it works miracles. And when you are a code reviewee, so your code is being reviewed, try to be open, try to be not stressed, that you did something wrong or stuff like this. Just be relaxed and be happy that somebody is reviewing your code. I love that my code is reviewed because that's the way I learned most of the things. I can spend time Googling around, but sometimes, you have no idea that something exists or that I can do something in a better way. And software engineers are in general smart people, so they always find a better way to do something. So try to be open, and and I hope code reviews will work for you. Okay, this is basically it. I hope you enjoyed it. I hope I convinced you that we have to train our skills, and I hope I also injected some good habits into your habit loops. Play with the frameworks, note it down. This presentation will be available online, and simply don't try using all of the things at once at your work because your boss will get a heart attack, but simply try one a week or one when you need it and you're going to be fine. Okay, and the last thing that I have for you is that is the famous quotation by the Speaker of the US House of Representatives, Sam Rayburn, who said that any jackass can kick down a burn, but it takes a good carpenter to build one. Thank you.